Okay. Um, let's to solve this optimization question. We can see the question is the minus 3x squared minus 3y squared and find this minimum. And this function is subject to the y squared minus x less than or equal to 1 and the 1 minus x plus x times y plus y is um, larger than or equal to 0 and 1 minus x minus y larger or equal to 0. We can turn this question into 3x squared plus 3y squared and find this maximum. Uh, yeah, by the way, this function subject to the y squared minus x minus 1 less than or equal to 0, and x squared x minus x times y plus minus y minus 1 less than or equal to 0. And you can see x minus y x plus y minus 1 less than or equal to 0. And second, we can construct the Lagrange function. Yeah, you can see in this. So we can do the first order condition. Let's we can get these two functions. Um, and then we will solve the Hazen matrix of the Lagrange. Yeah, and you can see in this, and this is the matrix of the Hazen matrix. Yeah. By the way, we also to solve these three constraints. Next, we listed the KKT condition. And you can see in these functions is all the KKT condition. Then we begin to classify the discussion. The first situation is the lambda 1 equals to lambda 2 equals to lambda 3 equals 0. In this case, we can get the condition is the 6x equal to 0 and 6y equal to 0. Thus, x equals y equals 0. And this is the start point. Yeah, we can do the second order condition is the you can see this Hazen matrix. And the determinant is the 36 is the positive definite. So this point is the local minimum. And the second situation is the lambda 1 larger than 0 and the lambda 2 equal lambda 3 equal 0. We can get this conditions and we solve the y, x, and the lambda 1. Yeah, in this case, we have three conditions. The first one is the y equal to 0 and x equal to minus 1. And the lambda 1 is the minus 1 over the 6 is less than 0. So this situation is no solution. So we just to continue to discuss the other two situation. The first is y equals to root of 2 over 2 and x equal to minus 1 over 2. And we check the constraint is all correct. Then we do the second order constraint, second order condition. We should find the Hessian matrix is this, and we solve the determinant is this. It's absolutely less than 0. So we can see the bordering history, the n is 3 and k is 1. So we should solve the last but one principal minor is this. And this determined is 6 is larger than 0. Thus, it is the local maximum. And the second situation is this. Yeah, we checked the constraint is all correct too. And the second order condition is the same but not same like the front one. On this In this case, the determined border history is larger than 0, and the last but one principal minor is larger than 0 too. So in this case, this is the local minimum. And the three situation is the lambda 3 larger than 0 and the lambda 1 equal to lambda 2 equal 0. And in this case, we can solve the x equal y equal 1 over 2, and the lambda 3 is 3. Yeah. Yeah. The same way we do the second order condition and border history. The border history matrix is this, and we solve the determinant is minus 12 is less than 0. And the last but one principal minimum is this, and the determinant is 36. It's larger than 0. In this case, this is the local maximum. And the fourth for the fourth situation is lambda 2 larger than 0 and the lambda 1 equal to lambda 3 equal 0. And we solve this x and y, but the lambda 2 is less than 0. So this is no solution. Oh, okay, let's get to the five situation. The lambda 1 larger than 0 and the lambda 2 larger than 0 and the lambda 3 equal to 0. In this case, we can solve the x equal to 0 and 1, y equal to minus 1. And the lambda 1 is the 12 over 5 and the lambda 2 is 6 over 5 and the lambda 3 is 0. So we do the second order condition. The Borden-Hessian matrix is this, and we solve the determinant is 25 is larger than 0. And in this case, we also do to solve the last but one principal minor is this, and the determinant is also larger than 0. Thus, it is the local minimum. Yeah. And we move on to the sixth situation. In this case, lambda 1 larger than 0, lambda 3 larger than 0, and lambda 2 equals to 0. In this case, we have two situations. The first is the y equals to 1 and x equals to 0, but lambda 1 equal to lambda 3 equal to 0. That's no solution. Okay, let's move to the second situation. The y is equal to minus 2 and x equal to 3. Lambda 1 is 10 and lambda 3 is 28. So in this situation, we can do the second order condition. The Borden-Hessian matrix is this. We do the determinant is I and larger than 0, and the last but one principal minor is this, and the determinant is definitely less than 0. So this condition is the local minimum. Yeah. And we move to the seventh situation. The lambda 1 equal to 0 and the lambda 2 larger than 0 and the lambda 3 larger than 0. In this condition, we also have two conditions. The first is this and the second is this. So let's discuss with these two. In the first condition, we do the second order condition. The Borden-Hessian is this. We solve this determinant border Hessian is the 9. It's larger than 0. And the last but the one principal minor is this. The determinant is -8 is less than 0. Thus, this condition is the local minimum. The second condition, we do the second order condition, and we solve the determined border Hessian is 180 is larger than 0, definitely. The last but one is it is, and the determinant is less than 0. Thus, this is the local minimum. And the last situation is the lambda 1, lambda 2, lambda 3, or both of 3 is larger than 0. We can see in this condition we don't have the suitable x or y to um, satisfy this function. So in this situation, there is no solution. So we can compare with this local maximum point and conclude the maximum. We can do it by calculation at the point -1/2 and root of 2/2, and we calculate the max is the 9/4. Thus, we can get the minimum is the -9/4. Yeah, that's all.